Hey guys, this is Lucas from Better Coding Academy, and in this video I will be explaining some technical jargon specifically relating to servers. So I've received these kinds of questions a lot where you might understand how to code something, but you don't really understand the terminology behind it, or you don't understand how to best apply it within an interview context. So what I'm going to try and do in this video is explain some of the more common terminology relating to servers. So let's jump straight into it. The first one I've got over here is called REST. And REST stands for Representational State Transfer, with the R and the E both coming from representational. It's a standard that's most commonly used with HTTP, and it's a common language which, when implemented properly, allows you to make changes to data, fetch data, get data, and basically just do a whole bunch of data manipulation. So this is usually involved in a sort of API, so a REST API with one or more REST endpoints, and we're going to be going over that terminology in a bit as well. So commonly, I personally work with a lot of JavaScript and node.js. So for example, in node.js, a REST framework would be Express. There are also REST frameworks available in pretty much every large programming language because it is just so fundamental to the actual way that the web works. So for example, when you're building a website and you have a front end and a back end, for example, your front end might be in React and your back end in node.js. Usually what you would do is you would use the REST standard to communicate information between your front end and your back end. So an API stands for Application Programming Interface, and it's a set of predefined rules for communication. So this is a little bit different to REST. REST is more of a standard, and API is more of a customized language which you can build on top of your REST standard. So let's use an example here. Let's say that we have an API specifically for working with videos. So you might have the ability to upload a video, you might have the ability to download a video, and you might have the ability to, say, delete a video, for example. So that would be 3 different features, and these features collectively would be called the API, because this is the interface with which we have made our system available. That's called the API. Your API may be accessible via REST endpoints. So then in that case, it would be called a REST API, which would mean an API that is defined using a REST architecture. An endpoint is the URL where a particular web service can be accessed. So a web service is slightly different to a website. A website is something which is visited by an end user, whereas a web service is typically accessed by other code or accessed by, for example, a front-end framework, or maybe even other backend code as well. I've just got 2 examples here relating to users. I've got post to https api.example.com/users. This might be the endpoint for adding a new user. And the reason for that is because post generally means to create a new instance of. So when you post to users, you're kind of creating a new user. And then if we do get to https api.example.com/users, then that might be an endpoint for getting all users. So notice how even though we use the same URL, by changing the HTTP method, it actually affects how our API should work. Now, once again, this standard here, post and get, this is something that we have to define ourselves, and we would customize it in a way that seems suitable to us. However, it doesn't have to be defined this way, but this is the way that is the most semantic and makes the most sense. Post and get are 2 examples of HTTP methods. There are other ones out there as well, and all of these are used within REST as part of the REST standard. Okay, so now moving on to different architecture types. The first one we're going to look at is monolithic architecture. So a monolithic API is one that basically has all or most of its endpoints in a single service or a process. So think of a monolith. I'm from Australia. The biggest monolith we got here is Uluru. So Uluru is like this huge rock, and you can kind of think of a monolith as being just, you know, that's literally what it means, right? But like, it's all of your services and all of the endpoints in a single place, all together in one big bundle. So for example, you might have a single node.js process that puts together all the endpoints for a particular service. So back on the video example, you might have your uploading video, downloading video. You might also have, like, I don't know, messaging and like registration for users, all of that in the same place. Then that would be considered a monolith. So this is mostly contrasted with microservice architecture. And I'm going to go into that in just a little bit more detail in just a second. But one of the big pros for Monolith is that it's really simple to set up and to build. And one of the cons, on the other hand, is that when you deploy, you have to deploy the whole thing as one, right? Because let's just say you found a bug and you want to update it, and you have to take your whole monolith offline and you have to put the new one online. And depending upon the size, that may take anywhere between, 20 seconds to up to a couple minutes. And also the other big downside for monoliths is if you have an application that is accessed, say, millions of times a second, or at some other ridiculous scale, then it becomes very difficult for one monolith to handle it. Whereas then if you wanted to scale that, you'd have to kind of duplicate your whole monolith, right? Because it's like all or nothing here. You can't just scale up certain parts which are more popularly used than others. So it really has poor scaling. And we're going to look at microservices in just a bit, which has much better scaling, and I'll go into that. So microservice architecture. So microservices, they each contain part of the whole services API. So imagine you have your big service here and you break it up into little chunks, and then each chunk would be considered a microservice. So for example, you might have one microservice to handle all video uploads and downloads, and then you might have one to handle payments, you might have one to handle registrations, and so on. So then you each have these individual microservices, and then when they need to communicate with each other, you have these like communication channels that are set up as well, which allow you to communicate between each microservice. So for example, when you handle a payment, you might need to verify the user has certain information, and you might need to get that from the user microservice. So then in order to do that, then you would contact the user microservice in like your architecture. So the main pro for this one is that each part can be replicated, scaled, tested, deployed, all independently to the others, and they can all kind of have their own database as well, and like their own data storage mechanisms and all that, because they're all so separate and they're all so like individually containerized and encapsulated. But one of the cons for this kind of approach is that it's obviously a lot more complicated, and it's much more difficult to architect than if you had just a monolith, right? Because you'd have to design everything properly, and also if you don't design it well, then speed can very quickly become an issue when you're making requests all over the place. And in many cases, it's really just unnecessary. So like even if you're handling like, I don't know, a couple thousand users, you might not even need a microservice. But then when you start to get to a really big size and microservices become an issue, then it definitely is worth considering moving towards a more microservice based architecture. So now the final one here, this is also, I guess, an architecture type, and this one is a little bit more modern in that it came out quite recently. It's called serverless. So serverless, even though the name says serverless, it's not really that there isn't a server, but it's more that you don't have direct control over the server. So it's kind of contrasted with typical server-based computing. Now both microservices and monoliths rely upon servers, or the concept of a server, an operating system, whatever you call it. But then with serverless, what you really do is you write your code and you set up configuration in a text file. Now what you do is you deploy this code and the configuration onto what is known as a serverless vendor. So examples of this, and you may have heard of these, include Amazon Web Services, Lambda, Google Cloud Functions, Azure Functions, and there are other ones out there as well, which essentially allow you to host your code. And then when someone calls a particular endpoint or API, then your code is run. So you can kind of hook that up. And say, for example, you have a particular bit of code which allows you to create a new user. So then you would have this code and say, let's deploy it on Lambda as a Lambda function. When your front-end code calls a particular API, then the Lambda function runs. And then when it runs, AWS realizes that you've, say, for example, run the function for 200 milliseconds, and it bills you a little bit of money based upon the amount of time that it ran for. So that's essentially how serverless works. Now, one of the big pros is that this means that you can have infinite scaling up or down. So for example, if 1 million people decide to call your code in even 1 second, for example, the only thing that's really stopping you here is AWS and their ability to handle all of this kind of stuff. That's really just a non-issue, because you're really not, it's not dependent upon your code or your architecture, because it just depends upon how much your code is run and how much money you've got in the bank. So it's infinite scaling up or down. And also if you suddenly have a, say for example, a burst period where like your company gets featured on the news, and you all of a sudden you have 1 million people visit your site, then you get billed for 1 million people visiting your site and how much that costs. But then also if the next day, then all of a sudden, you only have 1,000 people, then it all scales back down, and you don't have to pay the extra cost of servers for any bit of time that you're not using the actual service. So that's the big pro. That usually means that it's a little bit more cost efficient. But the con to this is that you're usually tied into a particular vendor. So for example, if you set up code for AWS Lambda, it's generally going to be quite different to the code that you'd write for Google Cloud Functions, for Azure Functions, and so on. This can be addressed. However, this isn't the only issue. I do think serverless is still not 100% there. I don't recommend it for the majority of projects. One of the reasons here is cold starts. Now, cold starts can make it quite slow. With JavaScript, you generally are looking at a cold start period of about 100 milliseconds, if not more. So what this means is essentially this period of time when the AWS or whatever engine has to like kind of start running. You can think of it that way. And then when it starts running, then it becomes hot, and then it becomes a lot quicker. But then that period of time usually takes about 200 milliseconds. But for certain other languages on serverless, it can take a lot longer. For example, C# and Java have been known to take up to 1 or 2 seconds, and that can make it basically unusable. That can definitely be a problem. Another issue is that when you're working with serverless, you end up with a lot of different things that you have to work with and juggle at the same time. It becomes quite difficult to architect your code in a way that is clean. So that definitely it's not an issue that everyone will face. And if you design it well, then you can mostly mitigate that issue, but it's definitely something worth considering before you jump straight into serverless, because obviously there has been a lot of hype surrounding it, and I just want to make sure that you make the most informed decision here. So that's all I've got for you in this video. I just wanted to go through some of these popular terms that pop up a lot relating to servers specifically within the web development industry. I hope you guys have enjoyed. If there are any other videos you'd like to see or any terms you'd like me to explain, please make sure to leave a comment down below and I'll try my best to address them as soon as possible. This has been Lucas from Better Coding Academy, and see you guys later.